Hi guys, in this video we're taking a look at active transport. Active transport, if you remember, is the transport that typically goes against the gradient, or maybe you're moving along an ion or a large molecule from one side of the membrane to the other. But typically we've been talking about it in the context of moving against the gradient. In order to go against the gradient, we're going to need ATP. So that word against the gradient, keep in mind that we use that illustration of a rolling ball going down the hill. The ball will naturally go down, it will diffuse down, it will go with the gradient downhill. But when you want to take it uphill, ATP is required. That is going against gravity or against the gradient. So typically the gradient is from high pressure to low pressure. But in this case, we want to take a molecule and go against the gradient from a low pressure to a high pressure. And in order to do that, we need ATP. And what will happen is that molecule will bind to that channel protein, that transport protein. And the ATP molecule will then bind itself to that protein. And that third phosphate group will release the energy from the ATP molecule and bind to the protein, making now ADP. So ATP has now been transformed to ADP, adenosine diphosphate. And that energy release will then change the shape of that protein channel, allowing the molecule then to go through against the gradient. Then the last stage, the last step, is when that phosphate group will detach, and that will cause the protein channel to reconfigure back to its original shape, making room for the next ion to get pushed along. And of course, in order for it to get pushed against the gradient, we're going to need another ATP molecule. So that, guys, in short, is the active transport, where we use ATP, we use energy to go against the gradient.